Hello, dear students. Welcome to DAV Moyle Public School. Today, we will start the fresh chapter of science, that is work and energy. Work and energy are very important concept in order to study day-to-day life applications. So, work first we will see what exactly do you mean by work. Work in general has a altogether different meaning, but when we talk about science, more specifically physics, it has altogether opposite meaning of what the definition of work says in real situation. If I consider a situation, as you can see, there are two situations mentioned in this picture. One person is trying to lift an object and the object has moved in upward direction. Here, in general, you will say this person has done a certain amount of work in lifting an object from one certain at a certain height. Whereas in the next situation, a boy is pulling his toy and the toy is moving from one place to another place. So in science, what exactly we will in among the two situations, which situation would be considered as a work when we talk about science? This situation won't be considered as work, whereas this situation would be considered as a work. Why is it so? Because the object has not displaced in certain direction. Since this person has simply lifted the object and the object has not moved from one place to another place, this person has not moved from one place to another place, and force is there, and force and displacement are in perpendicular direction. In that situation, there is no work done. Force is there and displacement is, whenever displacement is in perpendicular direction, there is no, we say that there is no work done. Whereas, as you can see in this situation, a force is being applied by this boy and this toy is moving in the same direction as the direction of boy. So here in this situation, in science, we will say this person has done certain amount of work. We will see in detail how this situation is works in generally, what exactly it is trying to say. So as I told previously, work in general, if anyone asks you what is work, you will simply say anything which represents physical or mental activity, that is work done. For an instance, if you are doing certain amount of homework, or rather you can say you are continuously learning for 3 to 4 hours, and after certain duration of time you feel exhausted, you will say I have done too much of work. But in general you can say, but in reality, in science, you have done zero work done. Why is it so? Because you have not displaced your position from one place to another place. Now what do you mean by displacement? You have not moved your position from where you are studying. You have not moved from one position to another position. Since we have not moved, in science, work done is zero. In general you will say you have done certain amount of work but in science, since you have not moved from one place to another place, in science no work is done. So work has a precise meaning in science. More precisely, this branch of science, that is physics. Work is said to be done when a force acts on a body and the body undergoes displacement. Whenever force is there and body undergoes displacement, what do you mean by displacement? An object moves from one point to another point when a force is applied by some person. When the object moved or shift from one position to another position, then only we say work is done, or else we will say the work has not been done. As you can see in this picture, a boy is trying to push the branch of a tree and the branch of a tree is not moving. After certain duration of time, the boy will get exhausted. He will even try, he will even sweat also. If anyone, he will say, I have done tremendous amount of work done in moving this branch of tree. But in science, the third person will say you have not done any work done. Why is it so? Because the branch of a tree has not moved from one point to another point. So this is not the example of, this is not the work done. Whereas this boy has pulled this cart and this cart is moving in certain direction. For initially the cart was in this direction. since this boy has applied certain amount of force and this cart has moved in a same direction. This cart has moved in same direction applied by this person towards this cart, and the cart got moved in this direction. Since this cart has changed its position, so you will say this person has done certain amount of work. Another certain examples are given over here. As you can see, aeroplane is moving from one point. This is an picture of aeroplane. Aeroplane is moving from one point to another point. So you will say it is a work done. Bicycle is there, car is there. All is moving from one point to another point. This girl is trying to lift chair. That is also work done and putting in some other position. Two different situations. As you can see over here, if I consider this situation, this girl has simply pull this chair in upward direction, and there is no displacement in chair. So the third person will say that since the chair has not displaced its position, so girl has done no work. No work is done by the girl. Whereas in the same situation, the two boys are located over here. Two boys are trying to push that cart in the same direction. As you can see, both are applying certain amount of force. This person is applying certain amount of force, this person is applying certain amount of force. Because both are applying same amount of force, this cart is not moved. So again, zero work done example. Again, if this person is trying to pull this cart, this person is trying to pull this cart. Since both person are trying to pull this cart and this cart has not moved from one point to another point, again no work done. So these three an example of no work done. Whereas this is also no work done, this is work done, this is work done, this is also work done, this is no work done. I hope you have understood the concept of work. So let's discuss some other thing. So we will deal this concept of work in higher classes also. So for that you have to remember certain things which will help you out. What is work done? Work done, it is always denoted by W, capital W. It is given by the formula W equals to force dot displacement, force into displacement. As I told, work done, that is W, which is equals to F stands for force and S stands for displacement. So work done is always the multiplication of force into displacement. F stands for force and displacement. Whenever force is there and body is getting displaced, so we say it is work done. So unit of work done, how we can get unit of work done? Since we know the force, we have studied previously what is force. The SI unit of force is Newton, and displacement, the SI unit is meter. So the SI unit of work done, as simply have to replace the formula, or you replace the units of force and displacement over here, you will find one certain new form of unit. That new form of unit would be the same unit as that of the work done. So work done, W is force stands for Newton and SI unit of displacement is meter. So we say SI unit, that is standard international unit of work, is Newton per meter, which is nothing but joule. Now let us see factors affecting work done. There are two factors which affects the work done. First one is the amount of force applied and the displacement of the object. The amount of force applied, which means how much intensity force is being applied to move a certain object. That is the first factor in which work done depends. Second one, how much amount of displacement is being done by the object. Displacement means how much distance the object has moved. That is displacement of an object. So work done depends upon two things: amount of intensity of force is applied, with how much amount of intensity force is being applied by a person, or an object, whereas how much distance the object has moved from one point to another point. That is the second factor. As you can see in this picture, two situations are given. This person is trying to pull this trolley with a certain amount of weight, and this person has moved 1 kilometer with his trolley. With the same thing, another person has pulled same amount of force, and with the same amount of mass, this person has moved 2 kilometer. So in what situation we will say more work is done? Since, as you can see, the amount of distance covered by this person is only 1 kilometer, whereas the amount of work done by this person is 2 kilometer. So work done, since the displacement is more, no matter the amount of force applied by the both person are same, but the displacement covered by this person is more. This person has covered only 1 kilometer, whereas this person has covered 2 kilometer. So more displacement is there. This person has moved more amount of distance, more displacement, hence this person has done more amount of work done. Now another situation is given over here. Now if suppose both person are moving, as you can see, two persons are over here. This person and this person has covered a distance of say 1 kilometer. Both has covered a distance of 1 kilometer. But as you can see, this person is carrying less amount of mass, those less amount of fruits over here, whereas this person is carrying too much amount of food, too much amount of mass over here. As you can see, this for this person less force is applied to move this cart in moving a distance of 1 kilometer, whereas in second situation this person is applying more amount of force. Since more mass is there, more amount of fruits is available over here, more mass is there, hence this person has done more work. Why is it so? Because more amount of mass, more amount of force are being applied by this person. Since more number of mass is there, because of which more amount of force has to be applied by this person, because of which this trolley will be moving. Since more amount of force is applied by this person, so the work done by the card D person is more as compared with this. I hope you have understood. So let's move with the next concept. Now, there are certain examples, positive, negative, and no work done examples. I've collected some pictures in which says positive, negative, and no work done examples. As you can see in this picture, there are certain examples. As you can see, this horse and this cart are both moving in same direction. Whenever force and displacement are in same direction, we say it is a positive work done. As you can see, this horse is moving in this direction with this arrow, and this cart is also moving in this direction. So the amount of force applied by the horse is in one direction, whereas object is also moving in the same direction as the direction of force. Whenever both the directions are same, we say it is positive work done. As you can see in this example, here a rocket is trying to launched. So the rocket is being launched, and you might be knowing that to launch a vehicle, an opposite force has to be applied. As you can see, an opposite force is applied in downward direction. Since opposite force is applied in downward direction, but rocket is moving in upward direction. So as you can see, force is in downward direction, but rocket has moved in upward direction. So force and displacement are in opposite direction. So we say it is a negative work done. Negative work done. Again, no work done example. This person both are applying certain amount of force, and this object is not moving, so no work done. This situation given if suppose this person is both the person are applying certain amount of force in their own direction with a certain amount of force. If you analyze this picture properly, this person is trying to pull this cart, and the force is applied over here, and for an instant this cart has also moved in this direction. So you will say, since force and displacement both are in same direction, so this is a positive work done. At the same instant of time, since this cart has moved in this direction, but this person is also applying certain amount of force. From this person perspective, force is applied in this direction, but the cart has moved in this direction. So for this person, the amount of work, negative, it would be negative work done. For this person, it would be positive work done. Again, this example is over here. A stone is there. A boy is trying to push this stone, and the stone is not moving. So, since the stone is not moving, the stone is not changing its position, so no work done. Now, another boy joined with this person, and both of them has displaced the position of the stone, and the stone has moved from one point to another point. So both of them has done certain amount of work. Now this person is trying to push the wall, but the wall is not moving. Since the wall is not moving, no work done. A person, as you can see, force is been applied by the person, and the force is in the force are being applied by the person in upward direction, and with the force of gravity, the force is also there, mg, acceleration due to gravity. With this combination, acceleration due to gravity is downward direction. You will understand this concept more precisely. For a time being, you have to simply remember, whenever force and displacement are in perpendicular direction, you will say it is always no work done. Here this person has done no work. Why is it so? Because force, as you can see, force is in downward direction, and this person is moving from one point to another point with this object, and the displacement object is in this direction. So force and displacement are whenever in perpendicular, or whenever they make an angle of 90 degree, we say no work done. Now again, a circular object is there. If a person, or an instant, if an athlete is running in a stadium, if the initial point when athlete starts to run was in this direction, and the final point when the athlete returned was the same direction as that of the initial point. So if anyone asks you, according to the definition of science, how much amount of work done by the athlete, since, as you can see, the displacement is zero. Why the displacement is zero? No matter the distance was distant object, the athlete has covered certain amount of distance, but displacement is where the initial point and the final point are same, so the athlete will has not done any work. So this is another no work done example, no work done example, no work done example. Now let us see what you mean by energy. Energy, it is simply the capacity or the ability to do work. Any object or any situation which has certain ability to do work, that is energy. For an instant, if I give an example, if a certain muscular person is there, he is trying to push, or he is trying to do gym and all, and he has developed a certain amount of muscles in his body. But and if another person is there, and both of them, if a normal person is there, both of them has has been told to run a certain amount of distance, but the energy spent the energy spent by a weaker person was relatively less, as well, whereas energy spent by the muscular person is more. Since, what exactly do you mean by energy? It is simply the ability to do work, the ability of a person, how fast that person can do his work, that is energy. In simplest word, we can say how fast an ability of a person or an object can do or accomplish a certain task, that is energy. So since previously we have discussed what is work, in the same thing, energy is also correlated with work is also related with energy. To as what was the same, what was the unit of work? It is the same unit of energy. We will understand this concept of energy in the next video also. So that's why I did not told in exact full-fledged. In the next slide or the next video, we will see about energy and different forms of energy. Thank you and have a nice day.